Hi everybody, here's the next video. We're going to talk about statistical tables and graphs. The first thing we're going to talk about is a frequency table. That is talking about some sort of a, subject or whatever, and we're going to talk about things in terms of, how many times does this happen? What is that in relation to the total number of times something's happened? And then we're going to add it all up too. So let's talk about number one, a website that reviews recent movies, lists five-star films, which is the highest rating, 10 4-star films, 20 3-star films, 15 2-star films, and 5 1-star films. Okay, they want us to make a frequency table for this data set, and then they say also include the relative frequency and the cumulative frequency. So what this frequency table is basically what are the categories, how many times do they happen, and then in this one they want you to include the relative frequency, meaning how many times does this happen in relation to the total number of times, and then they want you to include the cumulative frequency, which I'll show you when we get to it. So we're talking about film categories, right? A 5-star film is the best one, down to a 1-star film. So I'm going to call this first table, I'm going to call it ratings. Okay, because those are the different categories that we're talking about. And this is, again, what category are you talking about? You could name it something else. You could have called it stars or categories or, something like that. Movies, if you want. But this is what category. I'm going to erase this just because we're going to need all the room for this one. We had 5-star, 4-star, 3-star, 2-star, and 1-star films, right? I don't need to draw all the stars. You guys get the point. So those are the different categories that we have to group all of these films into. Okay, so the next part in our frequency table is the frequency. Frequency. Meaning how many times does it happen? How many 5-star films are there? In the problem it says we have 5 5-star films. Okay, how many 4-star films? Just go on down the list and fill this in, and I'll do it quietly too. Okay, hopefully that's what you got. Okay, so that gave us the 5-star films, there's 5, the 4-star films, there's 10 of them, the 3-star films, there's 20 of them, and so on. Okay, this is the very beginning of a frequency table. What are the categories and how many times do they happen? But the next thing they asked us to do was include the relative frequency. So I'm going to write it pretty small, relative frequency. Q-U-E-N-C-Y. Geez, I'm missing a lot of letters. Relative frequency. We're going to need room at the end, so you'll see what I'm doing. The relative frequency means, okay, there were 5 5-star films out of a total of how many films? Well, you could figure that out, right? Just add those all together. Out of 55, right? Because the total here, when I add all of these together, gives me 55 films. Okay, the relative frequency then is 5 out of 55, or you might have gotten, if you did it as a decimal, 0. I'm going to need more room. Hold on, I'm going to scoot this over. Hopefully you have a lot of paper. 5 out of 55, which as a decimal would be 0.09. In relative frequencies, they do usually want a decimal. So when you're doing my math lab, you'll probably have a decimal to the nearest hundredth, and we'll talk about why that can be confusing in just a minute. So you could also say this is what percent. 5-star films were what percent of the total number of films? About 9%, right? Because we know 0.09 as a decimal is 9% as a total. Okay, let's go on down the list. So it's 10 out of 55, right? The total's never going to change. And if you do the math on that, you get 0.18, which would be about 18%. And if you went out another decimal place, right, you would be able to see, 18 point what percent. And then keep going on down the list. This is 20 out of 55, This is 15 out of 55. We already did this one, right? We did it up here. When you divide 20 by 55, what do you get? Hopefully you get 0.36. And then here, I think you got 0.27. Okay. In theory, what should all of these add up to? They should add up to 1, right? Representing 100%. Just like when you add all of these numbers together, it gives you the total. When you add all the decimals together, it should add up to 1. If you actually add these together, you'll see you only get 0.99. Why is that? Well, because we rounded a little bit on some of them, so we rounded down enough that we lost 1%. That's okay. In theory, right? In theory, I'm just going to say it out loud. In theory, this should equal 1, which of course would be, which would be 100%. But our rounding issues there caused us to have a little bit less. That's okay. So this is what they mean. The categories, the frequency, the relative frequency. The next thing they ask for is the cumulative frequency. Cumulative frequency. That means we'll start with 5. Okay, so this frequency here is 5. We have 5 movies that are 5-star. We're going to add them up as we go down the list. So the next line, we would say this plus this. We would say 10 plus 5, which is 15. Okay, and the next one, we would say 20 plus 10 plus 5. We're just adding them all together. Accumulate, right? Fancy weather word. Means to how much precipitation did we get, how much added up over the period of 24 hours. Cumulative means we're just adding it all together. So the next one would be, here, let me draw a line. The next one would be 15 plus 20 plus 10 plus 5 equals 50. And the next one would be 5 plus 15 plus 20 plus 10 plus 5. And you should get, this is almost just like a double check to make sure, sorry, my head's probably in the way, to make sure you get a total of 55. And there's your answer for number 1. Let me erase. Go ahead and read through number 2 and 3. Again, you can always pause the video if you're like, wait, I'm not quite done with that one. Pause the video. Again, we're on 5C. We're going to talk about number 2 and number 3. Okay. So we're talking about quantitative data or qualitative data. What do you think quantitative means? This is a class called quantitative reasoning. What are we reasoning with? Numbers, right? Quantity, how many are there? So anything that's quantitative, just like our reasoning, is something that can be counted. Or has some sort of a numerical value. Quantitative, quantity. Anything that's qualitative, we're talking about the quality of it, meaning it's purple or it's happy. It's something that we can't count. It's something that we're just talking about its quality. So it cannot be counted. It's the easiest way. Quantity, it can be counted. Qualitative, the quality of it, it's, it's, I don't know, good. We can't count that, right, necessarily, but we could describe it in kind of a different way. So let's look at 2 and 3. Number 2 says the amount of rainfall, I didn't make this up, but I could have, the amount of rainfall each month of the year in Portland. Is that quantitative or qualitative? It's quantitative, right? Because you can count up how much rainfall there is. You can add it up or you can measure it. What about number 3? The breeds of 120 purebred dogs. Don't let them trick you into thinking that you're counting up 120 dogs. You're not. The breeds of dogs are what they're talking about. The breeds. It's a poodle. It's a lab. It's a golden retriever. Those are qualitative. We can't count them. We could count how many labs there are, but that's not what they're talking about here. They're talking about the name, the breed. So that would be qualitative. Number 2 is quantitative. And number 3 is qualitative. Okay. Look at the back page now and look at number 5. We're going to use the data set up here for number 5. Sorry, it's not the back page for you. It's probably page 2, not the back page. Mine's a double-sided. All right, so we have that data set, right? It starts with 89, 77, 67, 88. We're going to use that data set and we're going to answer number 5. The reason is number 4 would take up more room and it would get too messy, but I'll explain to you how to do number 4 once we do number 5. Just give me a second. So we're going to use that data set, those numbers, maybe they're grades. That's kind of what I thought they were, somewhere between 60 and 98, hopefully. They're all passing grades, I think, so that's a good thing. Let's look at number 5. So they want us to do the same thing we're doing in number 4. They just want us to use 10-point bins. What do they mean by that, 10-point bins? Well, those categories that we're going to set up, they want us to do in 10-point chunks, basically. So let me start on the categories, and then they just want us to do what we did in number 1 again. Make a frequency table, include the relative frequency and the cumulative frequency. So in number 5, remember I'm doing number 5 right now. I'm skipping number 4, but I'll explain it to you after. They want us to use 10-point bins. So looking at the grades there, you can do this one of 2 ways. You can go high to low or low to high. It doesn't matter. The grades are all between, this is harder to explain since we didn't do number 4, but what they mean is each chunk they want us to do with 10 points in between them. They want us to do like 90s, 80s, 70s, 60s. Does that make sense? And that's going from high to low. You could also go the other way from low to high. Since there's no 100, that kind of eliminates that. If there was the 100 and they asked us to do 10-point bins, we would have to go 91 to 100, right? Because 91 is 1, and then if you count up, 99 would be 9, and then 100 would be like the 10 points, but there's not. So our first bin, and I'm going to start you on this, our bins, we can call them. I'm going to move over because we are going to need more room. Again, this is number 5. So our first bin will be in the 90s. Then we're just going to keep going down. We'll go 80s, 70s, 60s. And we found, I think there are no lower grades than a 60, so we should be good there. So remember, this is like the category, or in the previous example, this was like the amount of stars the movie had. So these are bins, or these are grades. Okay? And then we're going to do the frequency next. The frequency. How many 90s are there? Between 90 and 99, how many are there? It might take you a minute to count them all up, so pause the video and count them up. Okay, there should be 5. Double check though, but there should be 5. How many 80s are there? Pause the video and count up the 80s. Okay, there should be 5 also. Go ahead and count up the 70s now. Okay, there should be 5 as well. This is kind of boring. And go ahead and count the 60s. Pause the video and count up the 60s. Well, this made it a little bit easy, but we know this is our first category, then the frequency happens to be a 5 for each of them. What's our next category title going to be? They asked us to do the relative frequency, so we'll do that. What's the relative frequency for the first one, and matter of fact for all of them? It's 5 out of how many? 20, right? 5 out of 20. It's a quarter. So we should know it's 0.25, or if we wanted a percent, it would be 25%. And matter of fact, it's the same. This just means it's the same. Usually we go like that. For every single one, it's exactly the same. All right, what about the cumulative frequency? Cumulative frequency. Well, this is 5. The next one is 5 plus 5 is 10. The next one is 5 plus 5 plus 5 is 15. I know this, sorry, I'm not writing it nicely. 5 plus 5 equals 10. The next one is 5 plus 5 plus 5. Just backtracking for a second. And the last one is 5 plus 5 plus 5. I know it seems redundant, but they're just trying to get you to, I think they're just trying to show you kind of that that's how you can check your work. And your total should always be the same number here. So that's how you do number 5. If we were going to do number 4, let's talk about the bins. I'm going to erase this. Look at number 4. I know I'm all over the place, but I promise you'll be okay on number 4. You should try it on your own though, because you will see questions in my math lab that are similar. They tell us right in number 4 how they want us to bin this data. The word bin kind of means group or chunk it together, how they want us to categorize this data. So they tell us the first bin, they want it to be 95 to 99. Okay, that's fine. So the next bin, they want it to be 90 to 94, right? We have to go up to 94 and then start at 95 because there is not any data in between the numbers 94 and 95. So we're making sure we're including all the data. So what's the next bin here that I would use? It would be 85 to 89, right? Because I'm going all the way up to 90, well, one number down, and then down to 85, right? 85, 86, 87, 88, 89. That's 5 points. And they ask us to use 5-point bins. And then just keep going down. You'll notice a pattern. Every 5 points. The next one will be 80 to 84. And what's the next one? 75, 79, 70, 74. You see how they all end in 9s, and then 4s, and 5s, and then 0s. And then just keep going all the way down. 65 to 69, and 60 to 64. Okay, now they want you to do the exact same thing we just did in number 5 with frequency, cumulative frequency, frequency, relative frequency, and cumulative frequency. So do the same thing with frequency, relative frequency, and cumulative frequency. Pretty good guess that since we're doing so many of these, and you're going to see them in my math lab, that you'll probably see one of these again. This would be when I would practice number 4. And if you get done and you have any questions, you can always feel free to snap me a photo, send me an email, and I'll look at it for you. I can double check. So that's number 4. Let me go on to number 6. Let me check our time. The videos, if they go over like 20 minutes, they take forever to upload. Oh, we're almost at 20. Well, we'll finish number 6 and then we'll be done. So frequency tables are one way to talk about statistical data. Another way, and I'm sure you've heard of this before, is a pie chart, right? A pie chart. Pie. Looks like this. It's a circle. What does this entire circle have to represent? 100%. Oh, there's a great, I'm going to have to email you this. Maybe I'll email you this. Maybe you've already seen it. I'll email you this with the worksheet. It was just on, I don't know, MSNBC or CNN or whatever. They put a pie chart on there and the pieces added up to like 175% or something, and people were tweeting and everything, and they were like, that's not how pie charts work. So you have to remember that the whole pie represents 100%. One whole pie always has to represent 100%. We're going to break this up into like slices according to how much, in this example number 6, according to how much each country will represent out of the total. But this is important to know. Okay, a pie chart could never represent more than 100%. Thinking of a good test question that could be on there. All right. So number 6 says the 5 leading tourist destinations in millions of visitors are shown below. Okay. So how are we going to take those numbers and split them up so that all of those visitors there represent 100% of the visitors. And then we can make a pie chart for each country. How are we going to do that? All of those visitors in total will have to represent 100%. So let's add up all of the visitors and come up with a total number. So you're going to add up France, 0.8. So France, US, China, Spain, and Italy. 59.7, 55.7, 52.7, and 43.6. So if you add all of these visitors together, you'll come up with a total number of visitors. Pause the video and go ahead and add it up. You should come up with 288.5. Okay, that represents the total number of visitors. If you just wanted to put one number in this pie, it would be 288.5, and it would be in millions of visitors. That's what the entire pie represents, and that's fine. That's actually true. But they want to know in number 6, how much does each country represent of this pie? So how can we do that? We can take, for example, France and say, okay, well, 76.8 is what part of 288.5? And we can do that simply by dividing. We'll get a decimal of 0.266, and we'll change that into a percent. So you'll get a decimal of 0.266, and you'll make it 26.6%. That's a decimal right there, 26.6%. So now you'll take that and you'll slice a piece of pie that's about 26%. Well, I know a quarter would be like here and then here. So I'm just gonna make it slightly more. So I'll write France at 26.6%. Okay, go on down the line and do that for everyone. I'll do the US next because it's next in line. I have 59.7 divided by 288.5. Remember, this is my total that I got. And I get approximately 0.207, Maine representing, which is 20.7%. So now I'm going to make the next slice of pie 20.7%. Well, I know this is about 26%, so I know the slice will have to be smaller. And I know if I drew a straight line here, right, and I drew it like this, these two pieces would have to add up to 50, right? That would be half of the pie, and I'm not quite there. So I'm going to draw the line a little bit. Instead of going straight down, I'm going to kind of go like this, right? A little tiny bit less, and I'm going to say the US at 20.7%. And we keep going around the pie. China, I ended up with 19.3%. Spain, sorry, my head's in the way, 18.3%. And Italy, I ended up with 15.1%. I suggest you go ahead and make sure you understand this calculation first before you just kind of copy me and label the pie. So pause the video, go ahead and look through this first, and then come back and I'll label the pie. So next, this is 20%, so 19's a little tiny bit less. It needs to be bigger than that. And the pie doesn't have to be perfect. We're just sketching it. It's okay if it's not perfect. You guys know how picky I am. So I'll just write China, 19.3%. Then I'll write Spain at 18.3%. And then Italy should be the smallest. Italy, 15.1%. And that's how you do it. All of these percentages, in theory, should add up to 100%. Again, if you get like 100.2% or 99.9%, it's because of some rounding issue somewhere, so don't stress out too much about it, but you should be very close when you add all of these percentages up to 100%. Matter of fact, I would check that like that news station needs to. All right, that's it for 5C. Hopefully you guys are doing well. Send me an email. Say, hi, I miss chatting with you guys. If you have any questions, of course, just let me know. Talk to you soon.